As we enter the final days of March 2026, the global astronomical community is operating at a fever pitch. We are now less than 2 weeks away from the spectacular climax of Comet C/2026 A1 maps, and the object is putting on a display that is rapidly exceeding all of our early expectations. Currently plunging through the star fields of the constellation, Cetus maps has already brightened past a visual magnitude of 9.3. Telescopes around the world are firmly locked onto its striking, glowing greenish-blue coma. This vibrant turquoise halo is fueled by the intense emission of diatomic carbon, which fluoresces brightly as the ancient ice reacts to the ever-increasing onslaught of solar radiation. Every single night, the comet grows visibly more active and volatile. It is presently sitting about 175 million kilometers from Earth, but it is closing the distance to the Sun at an unfathomable and accelerating speed. The initial shock of its discovery back in January, when it was spotted over 300 million kilometers away, is now paying off in scientific dividends. Scientists have used this unprecedented 81-day lead time to calculate its immense size and mass. Current estimates suggest the icy nucleus is up to 2.4 kilometers in diameter. This is a massive, heavy snowball by typical sun grazer standards, and its sheer physical bulk is the only reason astronomers hold out hope for what is about to happen next. As the days tick down, we are watching a pristine relic of the early solar system march inexorably toward a terrifying rendezvous. We are on the absolute verge of witnessing the ultimate cosmic stress test, and the entire world is waiting to see if this colossal block of turquoise ice can withstand the Inferno. To truly understand the extreme danger this comet faces, we have to look closely at the precise mechanics of its trajectory for April 4th, 2026. On this fateful day, C/2026 A1 will reach perihelion, which is the closest orbital point to the Sun in its highly elliptical 1,175-year journey. The mathematical numbers governing this encounter are simply staggering. Maps will pass a mere 160,000 kilometers above the blazing, turbulent solar photosphere. To put that into perspective, that clearance is only about a quarter of the Sun's own radius. It is a razor-thin margin in astronomical terms. At this incredible proximity, the comet will be traveling at a mind-bending velocity of over 550 kilometers per second, which translates to roughly 1.2 million miles per hour. The environment it will plunge into is hostile beyond human comprehension. Temperatures will soar into the millions of degrees as the comet cuts directly through the superheated plasma of the solar corona. This unimaginable, blistering heat will trigger explosive, violent outgassing, boiling away thousands of tons of frozen water, carbon monoxide, and trapped primordial gases every single second. But the searing heat is only half the battle. The Sun's immense and crushing gravitational pull will exert terrifying tidal forces on the comet's 2.4-kilometer solid core. These gravitational tides will relentlessly attempt to stretch, warp, and completely rip the nucleus apart, testing the structural integrity of ancient ice and rock that has remained frozen and undisturbed in deep space for over a millennium. It is a battle between structural density and the overwhelming power of our star. This catastrophic fiery gauntlet is standard procedure for the Kreutz family of sun-grazing comets, the specific orbital group to which MAPS belongs. Historically speaking, the vast majority of Kreutz comets are completely annihilated during their perihelion passage. They vaporize entirely under the extreme conditions, leaving behind nothing but a rapidly expanding ghostly cloud of dust that quickly dissipates into the solar wind. However, a select few with exceptionally large and dense nuclei have survived the solar furnace to become some of the greatest, most legendary comets in human history. The Great Comet of 1843, and the spectacular comet Lovejoy in 2011 are prime examples of sun grazers that miraculously emerged from the solar fires, displaying magnificent, sweeping tails that dominated the twilight skies. The ultimate survival of C/2026 A1 depends entirely on its internal composition. It all hinges on whether its 2.4-kilometer core is a solid, tightly bound chunk of ice, or if it is a fragile, loosely packed rubble pile. If it fragments too early in its approach, the comet will dissolve into a shower of smaller meteors that will instantly flash vaporize in the corona. But if the core manages to hold itself together, the intense solar radiation will illuminate the massive amounts of dust and gas blasted from its boiling surface. Through an optical phenomenon known as forward scattering, where sunlight is intensely refracted and reflected off the comet's dust directly toward Earth, maps could briefly reach an astonishing apparent magnitude of -4. This would make it mathematically as bright as the planet Venus, potentially rendering it visible to the naked eye, even in broad daylight. Because attempting to observe a daylight comet right next to the blazing sun is incredibly dangerous for human eyes and can instantly destroy traditional optics, the scientific community is relying on specialized, heavily shielded instruments to monitor the April 4th encounter. The Solar and Heliospheric Observatory, widely known as SOHO, which has discovered thousands of minor sun grazers over the past few decades, is primed and ready. Its coronagraph instruments are designed to artificially block out the direct, blinding light of the sun, allowing astronomers to watch the comet's high-stakes plunge in crisp, real-time detail. Additionally, massive ground-based solar observatories, such as the Inouye Solar Telescope located in Hawaii, are preparing to conduct high-resolution spectroscopic analysis of the comet's chemical composition as its outer layers furiously boil away. This will give us a pristine, unprecedented look at the raw, unaltered materials that originally formed our solar system billions of years ago. Meanwhile, countless amateur astronomers and professional astrophotographers are carefully positioning themselves for the immediate aftermath. While observers stationed in the southern hemisphere currently boast the most favorable viewing angles and the darkest skies for tracking its approach, everyone on the planet is holding out hope that a triumphant, surviving comet will grace the evening twilight by the second week of April. The sheer anticipation is highly reminiscent of the great historic celestial events of the past century, uniting millions of people across different continents in a shared, exhilarating moment of scientific wonder and discovery. Observatories from the Atacama Desert in Chile, where MAPS was originally discovered, to remote viewing outposts in Australia and South Africa, have all synchronized their tracking software. They know that the window to capture the comet re-emerging from the sun's glare will be incredibly narrow, demanding perfect timing and clear weather. If C/2026 A1 MAPS does manage to survive its brutal solar encounter, the Post-Perihelion show could be nothing short of breathtaking for millions of skywatchers. Astronomers confidently predict that the intense, relentless heating could trigger the formation of an exceptionally long and vibrant tail composed of ionized gas and reflective dust. If conditions align perfectly, we might see a spectacular sweeping tail stretching over 40 degrees across the night sky, making it visually longer than the entire constellation of the Big Dipper. For those looking up from their backyards, the comet would appear very low on the southwestern horizon shortly after sunset. Observers would first notice the intensely bright, greenish-blue coma, the undeniable signature of its glowing diatomic carbon, contrasting sharply and beautifully with the fading orange, pink, and deep purple hues of the evening twilight. From that vivid turquoise head, a massive, glowing, ethereal tail would fan outward, being pushed violently away from the sun by the sheer invisible force of the solar wind and intense radiation. Pressure, however, this magnificent astronomical display will be a fiercely fleeting one. Because of its extreme orbital speed, following the gravitational slingshot of the Sun, the comet will rapidly recede from the inner solar system. It will sink lower into the horizon, with each passing night slowly fading as the frozen nucleus begins to cool once again. For a few glorious, unforgettable evenings around Easter 2026, humanity might be treated to a true, once-in-a-decade naked-eye spectacle. It will be a fiery, turquoise ghost ship sailing silently through the twilight, offering a phenomenal photographic opportunity before it finally disappears back into the freezing cosmic dark. Ultimately, the incredible unfolding story of C/2026 A1 maps is a powerful testament to our rapidly evolving relationship with the universe around us. We have successfully moved past the initial chaotic waves of wild speculation, extraterrestrial rumors, and alien conspiracy theories that so easily dominate our modern, hyper-connected digital world. Instead, we are left with a scientific reality that is arguably even more profoundly beautiful. We are tracking a pristine, ancient artifact of the deep cosmos as it performs a dramatic high-speed, kamikaze dive toward our host star. Whether MAPS is completely consumed and vaporized by the sun's wrath on April 4th, or whether it emerges battered, fractured, but victorious to brilliantly light up our evening skies, it has already provided absolutely invaluable data to planetary scientists worldwide. It has definitively proven the impressive capabilities of our early detection automated networks, and it has offered an incredibly rare natural laboratory for studying extreme thermal physics and orbital dynamics in real time. As we count down the final tense days to perihelion, the entire scientific community and stargazers alike are watching with bated breath. We are tracking a 2.4-kilometer mountain of turquoise ice hurtling toward a 160,000-kilometer shave with a roaring cosmic fusion reactor. This is the absolute ultimate drama of celestial mechanics, playing out right above our heads. So keep your telescopes focused, prepare your cameras, and keep your eyes locked on the western horizon, because the grand, fiery finale of Comet MAPS is finally about to begin. The universe rarely offers us such a perfect front-row seat to its immense power, and this is one cosmic show you will not want to miss. Thanks for watching, and if you would like more of these factual documentary videos, please consider subscribing and click that like button.